So in this problem we are going to solve one of the problems that was given for homework, where what you're given is you're given a chain of, say, length L of mass M, and there is a scale underneath this chain, and the question is, what is the reading on the scale, okay, when an amount X of the chain has fallen. So if an amount X has fallen, what is the reading on the scale? So it's a problem that involves a change in mass in the situation rather than a change in velocity. Now what you've also been told is that the mass, each link in the chain, it comes to rest as soon as it lands on the surface. Okay, so the reason the force is going to be, or rather there is going to be a force exerted on the scale, is going to be because of the mass that is already on the scale, which is this part, okay, along with the additional mass that that lands on it. So there is a change, there is a continuously, the mass is changing on the scale, so that change in mass is also going to exert a force on the scale. So here's basically how we'll approach this problem. We're going to use a relation that F is equal to d by dt of P. F is nothing but dP by dt. Now in this case, the speed, the velocity of all the stuff on the thing is not changing, so the only thing changing is the mass. So when we put this, the reason there is a force is because there's a dm by dt multiplied by v. Now if we were to complete the differentiation, we would have this also, but the second term simply is 0 because there is no change in velocity of the object. All that's happening is that the mass is getting added. So the reason there is a force is because the mass is increasing. Okay, so our goal in order to figure out this force is to find the mass, and once we know the mass is a function of position, we can then differentiate it with respect to time and figure out what the dm by dt is. Okay, so there are two components. So this is let's call this the force 1, which is the force due to the falling mass. The second force is due to the mass that's already on the table. So if it falls an amount X, there is some amount X, and we can figure out the mass for whatever is on the table, and we can then use that also to calculate the total force. Okay, so what we know is that when an amount X of the chain has dropped, the amount of mass at any time on the table is equal to m over L. So this is m as a function of X, okay, m over L multiplied by X. So this is the amount of mass that is on the table. But what we know is that this is changing continuously. So now here I can do dm by dt, okay, which happens to be equal to m over L times dx by dt. Okay, so dx by dt, as you know, is nothing but the velocity. So we have m over L times v squared. Okay, now also from our 1D motion, what we know is if an object falls a height x, the speed it gains is nothing but square root of 2gx. Okay, so this implies that dm by dt is equal to m over L times 2gx. Okay, so this is the so this gives us rather not m over L, it is simply no, I made a mistake here. What this gives us is, this is my total force, which is dm by dt times v. Okay, so the v square all cancels out. So this is one part of the force. So the other part of the force is due to the mass that is already sitting on the scale, and that happens to be simply m over L times x. This is the amount multiplied by g. So the total force is the sum of these two forces, and we end up getting 3 mg over L multiplied by x. Okay, so once again in this problem, what's happening is that the reason the one force is simply due to all the mass that's sitting on the scale, and the second one is because of the change in the mass. The change in the mass also adds a force, and that force ends up being twice mgx over L, and so the total force is equal to 3 times mgx over L.